Goose's Guidance Part 3 on the Boeing 747-400 in Miami. Goose is boots on the ground in Miami. And again, really good questions. And here we go. So the maximum tailwind component, just think of it as 10 knots. It is 15 knots on the 109 on the passenger airplane. But the combi and the freighter are 10 knots. And Boeing kind of makes a statement, while the aircraft's capability on 109 for the passenger version has been demonstrated for manual and automatic landings with tailwinds up to 15 knots, Boeing often notes that this does not constitute automatic operational approval to exceed 10 knots. So most airlines take the view of 10 knots max tailwind. So if you're in the freighter, it's definitely 10 knots. If you're in the passenger, you could go up to 15 knots, but again, a lot of airlines will limit it to 10 knots, no more than 10 knots tailwind. The GE CF6 normal duty cycle, that kind of varies depending on where you look. It can be tailored to an airline's needs, but I would generally just think of it as 1 minute on followed by 1 minute off. I think the 1 minute, 75 minute you referenced in the question was that's the APU starter duty cycle that's in limitations, but that's not the engine starter duty cycle. So generally just think of it as 1 minute on followed by 1 minute off. And that's a conservative limit. That's intended for daily gate starts to minimize the wear and tear on the starter motor. Maintenance, you can see in the maintenance manual, they have extended duty cycle limits, and they're quite extensive. So, for attempt 1, you can go up to 5 minutes on and then off until the N2 is at 0%. And then attempt 2, you can go up to 10 minutes on, followed by a 20-minute cooling period. And then attempt 3, you can go up to 15 minutes on, followed by a 30-minute cooling period. So you can see those longer cycles are used by maintenance or engineers for tasks like fuel system priming, compressor washes, or leak checks according to the maintenance manual. So you can see 1 minute on and 1 minute off is really conservative for the starter. So just think of it as that. Again, airlines can tailor that a little bit. They have some latitude in that. But for your purposes, for training, just think of it at 1 minute on, 1 minute off. In the A320, it does have overfly logic in the FMS, but in the 400, there is no overfly waypoint logic. So if you did have to overfly a waypoint, you could do so by, because normally the FMC will lead the turn when you're in LNAV, and so you may not pass right over the waypoint. So if there's ever a time where you do need to pass over the waypoint and not lead the turn, and I've never seen that myself where somebody requested that as far as ATC goes, that you have to fly over the waypoint. But you could do so by leading the turn. So as soon as it is close to where it's going to turn, you could go to heading hold or heading select and then fly over the waypoint. And then you could either continue to use heading select or rearm LNAV, and then LNAV would go to the next waypoint from that present position over the current waypoint. So yeah, you're correct. No overfly logic. There's no way to do it other than go into heading hold or heading select. I think your question was, before you execute, is there some way, in case ATC will take you back on the original route, that you can do something about that? And yeah, you can. So you'll see that on the prior to the modification, or prior to the execution of the modification, you will have the three things on the right there: beam points in R4, route copy in R5, and then the intercept course 2 boxes in R6, and then of course with the execute light on. You're proposing to go to XYZ. You would get rid of ABC, CDE, FGH, IJK, and you'd go direct to XYZ. But if you do a route copy prior to doing that, then if ATC says, hey, sorry, or the next controller says, sorry, you need to go direct to CDE, flight plan route, well, you could go to route 2 then, and that would be in there, and then you could make the modifications and go to CDE, and the rest of it would be in there. Of course, if you didn't do a root copy, then yeah, you'd have to do it manually, like you said. The speed brakes extended ICAS message, we mentioned that again. That caution message will come out when any one of the following occur. So if the aircraft is between 15 feet and 800 feet, you get it. With the flap configuration, if the flap lever is in a landing setting like flaps 25 or 30. And then for the thrust position, if 2 or more thrust levers are not in the idle position. So generally, if you're not in the landing configuration, if you're using speed brakes, then as soon as you would start to level off and thrust levers start to come up, 2 or more thrust levers would trigger that message. That's a direct result of that accident you mentioned, the one in South America with the 757, I believe it was, and where the boards were out, and they put the wrong waypoint in, and it said select desired waypoint, and they picked the first one, and the first one was not the one they really wanted, and so the airplane turned and went into mountainous terrain, and then they were in a descent, and the boards were out, and this ICAS message was a direct result of that problem. Of course, you said, why don't we have a message when you have the boards out, period, to warn you that the boards are out? Well, Boeing just didn't do that. Again, it is a caution message that you'll get for the speed brakes extended ICAS message, but when the boards are out, there's nothing that tells you the boards are out. So, basically, we always say keep your hand on the speed brake lever when the speed brakes are extended. Don't take your hand off it. And, for your question, I don't know why Boeing didn't put a message for that. My opinion is they could have made it a memo message. At least then you've got a message when the boards come out. You would kind of see it pop up as a white memo message. And then that would at least be some indication, because that's a normal operating condition, that you use the speed brakes. And so that would be, to me, a solution for having a message when the boards are out. Make it a memo message. But I'm not Boeing, and nobody asked me, so. But to me, it's not a bad idea to have it as a memo message. Why no go-around checklist after a missed approach? Well, the Boeing philosophy is you treat a missed approach as a transition back into the climb phase. So once the aircraft reaches the acceleration height and the cleanup is complete, with the flaps retracted, and you've selected flight level change or VNAV, and you retracted the flaps, then you're simply going to call for the after takeoff checklist, and that is the cleanup or the go-around checklist that you're referring to. It's really just the after takeoff checklist. So Boeing didn't see a need to have a specific go-around checklist after a missed approach. So you just use the after takeoff checklist in that case. Let's see, a manual start abort. If you don't have auto start, or auto start's not working and you have to do a manual start, as I recall, this is just what I recall, when you're doing manual starts, if the EGT, the key is that it's rising rapidly. It's not rising at its normal pace. You want it to go to cutoff around 400 to 500 degrees Celsius to prevent it from going over the red line limit. Now, I could be thinking of the Pratt & Whitney 4056 engines, which have a lower red line limit than the GE engines do. But generally, I think it's the same. Boeing, we used auto start, and we did have manual start problems. And even with the manual start problems, when you did it on a lesson, I think it was right around that 400 to 500 degree point. If it's rising rapidly, go to cutoff, because you're going to get some peak over that. And so you might end up at 600-700 degrees, but you're going to be under the red line limit. The key is you don't want to wait till it's almost there, because then if you go to cutoff, it's going to spike still a little bit, and you could end up exceeding the red line limit, and it'll turn red. And so you do have to lead it by a little bit. So kind of take this with a grain of salt, but I believe it was right around 400 to 500 degrees and rising rapidly. And you'll get the feeling for that. But just don't wait till the last minute before you go to cutoff. With an auto start or a manual start, if you abort the start, your memory item would be fuel control switch to cut off if it's a manual start. If it's an auto start, you're going to get the ICAS message after 3 attempts usually, and then you'll get the beep, 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 and it'll say auto start, engine auto start 1 or whatever. And then the captain would call for the checklist, and of course the memory item would still be fuel control switch to cut off. And the first officer will read, and this was your question, the first officer does read, and he does all the actions except anything to do with the fuel control switch. That'll be the captain's duty. So the captain keeps his hand on the fuel control switch, and if there's another start attempt, like on a manual start, and some engines you can attempt another start, and if when you get to the point on the checklist where it said fuel control switch to run, then the FO is not going to do that, the captain's going to do that. But everything else the first officer reads and does, basically, and the captain follows along. And that was, I think that was kind of your gist of your question. Flight control check, you said, why captain only? Well, it's, mainly it's a Boeing procedure. You could change that, and airlines do change it to where, the FO might do the ailerons in the elevator and the captain could do the rudders. That's a thought that can be done. But the Boeing procedure is that it's captain only. And the reason is that, the captain's going to make slow and deliberate inputs one direction at a time. And so his attention is on making the control inputs and feeling if there's any binding and that it's smooth and it's deliberate. He's not slamming the control column to the stops. And the first officer is monitoring the ICAS synoptic to verify that the surfaces are moving in the correct direction and that they're going to full deflection. So you're kind of splitting the duties between the captain and the FO there on the before taxi procedure. And what that does is it really, by having the captain perform the entire check, the captain will receive direct tactile confirmation, like you see here, that the primary flight controls are responsive and unobstructed. And so your duties are split there, whereas it complicates it a little bit if you split the duties where one guy's doing one set of controls and the other guy's doing another set of controls. So Boeing just believes it's better that the captain concentrates on one thing and the first officer concentrates on another thing, and you're not mixing and matching. So that's kind of why. And I think that's good. Electrical power down. I think your question was, why is the window heat not turned off? It is in some airplanes, like the 757, the older generation airplanes, it was turned off on the electrical power down. But then Boeing decided the switches like window heat don't require being off during shutdown because of the aircraft's electrical logic. So the electrical power down procedure, when AC power sources like the APU or external are removed, the system's de-energized. And this is kind of what you were saying too, that even though the physical switch remains on, the system is off because the power has been cut off at the source. And this aligns with the goal that normal procedures utilize automated features and logical flows to minimize crew workload. So basically they see there's no need to because it does it automatically. And so the other thing is that it will prepare the aircraft for the next time the power is applied, the window will start heating right away. So as I said, in older aircraft like the 7576, it did have you turning off the window heat. However, in the 400, and this goes for 777, 787, they streamline it. So by leaving the switches on, the aircraft is essentially pre-configured for the next crew when you do establish power, or maintenance when they establish power. The window heat will come on automatically. And I think that probably answers your question on why the window heat is not turned off. APU usage during flight. I think your question was why not use the APU and then turn it off. But of course, remember the APU it can provide bleed error up to 15,000 feet, and then the APU will continue running to 20,000 feet. But it can't supply electrical. It is prohibited or inhibited from supplying electrical power once you're airborne. So leaving it on really provides zero electrical redundancy. And the 400 and the Dash 8, both of them, when you have 4 engine generators, any 2 main power sources are sufficient to supply the entire electrical load. So taking off with the APU running simply wastes fuel and increases wear unless you need it specifically for an APU to PAX off takeoff or something like that. And that procedure is in the supplemental normal section. But again, that's just for bleed error. So again, no real need to, because number one, you don't have electrical power anyway. When you take off, you can't get it. It's locked out. And number two, even if you could have electrical power, 2 main power sources are sufficient to power the entire electrical load. So why run the APU? It's not a 2-engine airplane. That's the main thing. It's a 4-engine airplane. Aileron trim is right there on the control column. It's in units. And so we're checking that it's, we say 5 units, 0 and 0. The 0 is the rudder trim and the 0 is the aileron trim. You just kind of look over the control column and you'll see it there on the, right on the control column that it's 0. It's not, off to one side or the other. Control column straight. Again, I think you said I didn't show that in the lesson, primarily because we don't have a control column sitting there with the arrow links. Emergency evacuation. Let's see, your question here was, I can't remember what the question was. For an emergency evacuation, the primary objective is to get everyone off the aircraft as quickly as possible. Once a life-threatening situation is identified, and the procedure, of course, is to stop the airplane, assess the situation. If we determine we need to evacuate, then we do the evacuation checklist, not from memory, but on the back side of the QRH. And that is to set the parking brake, outflow valves to manual and then open. And that's a critical step because you can't open the doors if there's any residual pressure. So even though they should be open, we're still going to manual and putting them open to make sure that there's nothing that could prevent the doors from opening. And then fuel control switches to cut off, and that's going to shut down all the engines. And then we advise the cabin to evacuate the aircraft. This is sometimes done wrong by people. They get in a rush and they stop the airplane, especially when this was a memory item. And that's one of the reasons they went from memory item to, hey, let's just read and do it. And I've seen it multiple times where people stop the airplane. They kind of, even in the simulator, get a little excited. And then they get on the microphone right away and go, evacuate, evacuate, evacuate. And the engines are still running. So we do it methodically with a checklist one by one. And after the fuel control switches are cut off, that's when you make the announcement to evacuate over the PA. And then fire switches pull and rotate. This still doesn't get to your question. I think your question was, maybe it was here. I think it was, what do you do specifically for an APU fire versus a cargo fire? Certainly both situations could lead to an evacuation, but the management of the fire extinguishing agents differ. If it's an APU fire and you're on the ground, the APU normally is going to shut down automatically and discharge the extinguisher as well automatically if a fire is detected. And if an evacuation follows, you're still manually pulling and rotating the APU fire switch to ensure it is discharged, but it may be already discharged. With a cargo fire, you're pushing the cargo fire arm switch, which configures the packs to starve the area of air, and it arms the cargo fire bottle squibs. However, during the subsequent evacuation, you do not discharge the engine or APU fire bottles unless there is an actual fire indication in those specific areas. And then, of course, the checklist would direct you if there's a cargo fire on the ground. You have to warn the ground personnel, don't open any cargo doors until all the crew, if it's a freighter, or all the passengers and crew, if it's a passenger airplane, have exited the airplane, because if they open the door, the fresh oxygen could cause the fire to flare up. So I think your question was, if I remember, was just how to handle this, maybe the emergency evacuation and the difference between a cargo fire and an APU fire. But again, there's the steps, QRH, backside, step by step. You just follow it. You don't necessarily rush. Let's just take it step by step and do it as per the checklist. And again, APU fire, we're going to discharge the bottle manually, even though it may do it automatically. In the cargo fire, we're not necessarily discharging any engine or APU unless there's an actual fire indication. I think that might answer your question. If it doesn't, just shoot me another email and let me know. This is still part of that question, I guess. So and I think that was one of your questions, how do you exit? So with a passenger airplane, the entry doors are primary, and of course the doors are going to be armed. And when you open the door, the automatic pneumatic assist would throw the door open, and the slide bundle there would deploy automatically. If it didn't deploy, then they'd have to pull the handle. Of course, they'd pull the handle anyway, but in their training, the flight attendants. And of course, if you have to exit from the flight deck, it'd be via the overhead hatch. So if the main stairs or the upper deck doors are blocked, the crew can use the overhead hatch, and you have the inertial reels. And then the escape devices, you'd remove them and go out the overhead hatch and ensure the cable is securely fastened to the airplane structure, and then you exit through the hatch and hold the handle, and there's a inertial reel limits your descent speed as you ratchet down the airplane. I wouldn't want to have to do that for real, especially if you're not in shape or you're a little on the pudgy side. Might be hard getting out of that overhead hatch. But normally you're not going to do that unless you absolutely have to. Another question was checking the RMP value. And for the 400 and the Dash 8, the FAA approval to conduct GPS approaches using the FMS as the primary navigation source is predicated on the use of that RNP 0.3 or smaller. So the FMS will typically transition between the different default RNP values as the aircraft moves through the various phases of flight. In the terminal area, the default is usually RNP 1, and then during the approach phase, the default RNP would be, depending on what kind of approach it is, non-precision approaches like VORs or NDB, if there are any anymore, would be a 0.5. But specifically for GPS, RNAV GPS approaches, it'd be a 0.3 nautical miles. And normally that's going to change automatically, but if it doesn't, you do have to change it. It will normally appear when the final approach leg becomes active or up to 30 nautical miles prior to the preceding leg, if the preceding leg lacks an associated RNP. And so because the accuracy of the FMC position is critical for terrain and traffic separation, you have to monitor the relationship between the ANP, the actual navigation performance, and the RNP, the required navigation performance on the Position reference page, which is page 2 of the position page, or the R&P progress page, which is off of the progress page. So either one of those, you can see the R&P value. And if the displayed R&P doesn't match the requirements, then you have to put it in manually, and then it goes from small font to big font. And but again, if it shows normally, if it changed automatically and it's fine, you don't have to mess with it. But you do have to check it. Tank to engine, I think your question was, why do we, could we do tank to engine before we actually get the tank to engine message? And the answer is no, you want to wait for the tank to engine message to appear before you clean up that fuel configuration. So the fuel system management cards, those FSMCs, are designed to trigger that message only when the inboard main tanks of 2 and 3 are equal to or less than 1 and 4. Usually it's a little less. And you want to wait for the message because, again, Boeing procedures specify that you only will turn off both override pumps 2 and 3 to off and close the cross-feed valves 1 and 4 once the message is displayed. And I put this, why not early? Well, cleaning it up prematurely could result in an imbalance or unused fuel in certain tanks, as the system is optimized to use the center and inboard fuel first to manage structural wing bending relief. So generally you don't, you know, could you? Yeah, you could, but we don't want to mess with doing it early. So normally just wait for the message. If the message comes at an inconvenient time, you can wait until it is a convenient time to go tank to message. Like if you're in the missed approach and you see tank to engine, we don't really care. We're going to clean up the airplane. And when the workload is less and you've completed checklists, you know, then do the tank to engine procedure there for. And by the way, you don't have to use the checklist for tank to engine. It's the crews know what to do, and so it's not a checklist item. It's that's one of the things that's not a checklist item. You can just turn off overrides 2 and 3 and then close crossfeeds 1 and 4 because it's done all the time. It's a normal procedure. So missed approach, if the message appeared after a missed approach, it's likely the high fuel flow during the go-around finally brought the inboard tanks down to the trigger point, and then descent and approach. While you verify the fuel status during your descent procedure, you still only execute the configuration change if the ICAS message dictates it. So, yeah, we wait for the message. Reverse thrust usage on a check. You were asking about that. And I think the question was, what does the instructor examiner expect to see when you initiate reverse thrust? Is it immediately after the main landing gear touchdown, or is it after the nose gear is on the runway? Boeing explicitly says immediately after the main landing gear touches the runway, not the nose is on the ground. You could get pushback on that, however, and you probably would have gotten pushback on it from me if I was your instructor. So I've probably been teaching this wrong for a number of years, because when I looked into this, true enough, it's when the main landing gear touched the runway. And the reason is because, and we all know this, that the reverse thrust is more effective at high speeds. You could still take the opposing view, like I did for a long time, is that if you go into reverse, there's going to be an upward tendency for the nose to want to come up. But again, we counteract that. You counteract that naturally with the control column, and then you guide the nose gear to the runway. You don't hold it off and hold it off and hold it off. It's a controlled, it's not a slam down to the runway, but it's a controlled pressure for the nose to naturally come down to the runway. So if you were to go into reverse right after the main gear touchdown, there is going to be a slight nose up moment that you're going to counteract with control column pressure. So you could get pushback on that, because I think at Boeing we all taught it that way. I don't remember ever teaching it any other way than, well, wait for the nose to get down the runway. Well, that's actually not right. You can defend it by referencing the flight crew training manual in there. You can look at that as 6.32 if that's the current flight crew training manual page, but it's right in that area probably. And the why behind the logic is, again, that you don't want to wait for the nose gear touchdown. Again, Boeing clearly says that. The drag from the reversers is most effective during high-speed portion of landing. Now, again, the pushback, the reasoning I always used was if you went into reverse thrust and one reverser came out and the other had a problem and didn't come out, and your nose is still in the air, that could be a problem. I still kind of maintain that. However, by waiting for the nose gear to come to the ground, number one, the thrust reversers aren't going to be as effective, and you're really putting more wear and tear on the brakes. And so this is why they normally will say immediately when the main gear touches the runway, you can go into reverse. So that's the answer. The answer is actually what you were saying. And certainly I would have been one, if you asked me that I would have given you pushback on it and said, no, you want to wait till the nose gear gets to the ground. Well, that's actually contrary to what Boeing says. And I've seen people, and I saw a couple people do this on like YouTube videos, where somebody's flying the 400 and they touch down and they're going into reverse. And I was like, oh, you should wait till the nose gear. Well, I was wrong. He was right. He's doing it correctly. He started the reverse when he landed, when the mains were on the ground. So the right answer really is, yeah, you can bring the reversers out immediately after the main gear touches the runway. You don't have to wait till the nose is on the runway. And you can see here, immediate deployment allows the spoilers to deploy sooner. Of course, if they're armed, they're going to come out automatically anyway. But when you go into reverse, if they weren't armed, then that's when the spoilers are going to come out, if they didn't come out when they're in the armed position. Of course, again, the main weight on the landing gear is the main thing. Weight on wheels is important because that's going to improve your braking effectiveness. So that and brakes are still primary. Reverse thrust, again, isn't counted for stopping when they do certification. And that's another reason why we never, probably at Boeing, we never said you necessarily have to wait for or we said you do wait for the nose gear. Anyhow, the applying reverse before the nose gear is down introduces a slight pitch-up tendency. We talked about that. But the pilot's role is to control that manually by flying the nose wheel smoothly onto the runway rather than waiting for them to fall naturally. But it's more of a feel thing. It's not like you're pushing forward. You're just kind of guiding it. You're just watching the nose, and you're putting maybe a slight pressure there for the nose to come down. But again, I've seen many people wait till the nose gear is on the runway, the nose wheel is on the runway before you went into reverse. So this hasn't been stressed, but again, Boeing clearly says it. I don't know how we all missed it, but it clearly says that you can do it when you touch down. The only time you'd wait for the nose wheel to be firmly on the ground is during a non-normal situation, such as a nose gear failure or certain hydraulic malfunctions. And then you'd want to ensure directional control before you would introduce any kind of asymmetric or high drag force. And the QRH would tell you the appropriate course of action if that's the case. So that was a good question because I learned something there and something that I've been teaching for years. And, it's not the Boeing line. The Boeing line is you can do it on touchdown. Fuel jettison, yeah, you're absolutely correct. The trip fuel is the critical gotcha in the fuel jettison planning. In the simulator, normally you're right around the airport. And so there's nothing wrong with obviously using what I had said in the video, which is your zero fuel weight plus what fuel will give you the max landing weight, and that's how you can figure it out, by going to the perf and hit page and seeing what your zero fuel weight is, and then saying, well, what added to my zero fuel weight will bring me up to the maximum landing weight. But in reality, you may not be close to the airport, in which case then you have to take into account that you still have to fly to your destination, and what about alternate fuel and any kind of reserve, and so you're going to have to take all that into account. And that's what you were saying, and that's absolutely correct, that you'd have to take that into account to figure out your fuel to remain. And there's the formula there. Max landing weight minus the zero fuel weight plus your trip fuel to the alternate and required reserves. And you were using the example of over the Atlantic there with the alternates. On some of the newer airplanes, you've got the and I think the 400 has that option too, where you could have the max landing weight position, and you don't have to figure it out. You just go to max landing weight, but that will set the fuel to remain to the amount required to reach that exact weight. However, it's important to understand it's a snapshot based on the current FMS data. You still have to monitor the alternate page and for your arrival fuel to ensure that the predictions haven't changed due to any kind of config change or atmospheric change. If you go to that MLW position, max landing weight position, it's a convenient position so you don't have to figure it out. But you still have to monitor that that's going to be accurate. And if your reason for diverting involves a non-normal configuration, such as the gear down situation, I think we discussed that in FTD-8, your fuel burn will be significantly higher than the FMC's standard clean predictions. So in that case, you have to refer to the gear down performance tables in the QRH to then manually calculate a more conservative trip fuel additive before starting the dump, if you had some configuration that's going to affect the calculation. So yeah, you're absolutely right. You have to do the, but again, in training, there's no reason to do that because you're not far away. You're right there at the airport or close to it, and you're doing the maneuver to go back to the airport. So in that case, the zero fuel weight plus what brings you up to the what fuel brings you up to the max landing weight. Runway required for takeoff and landing. You asked about that. We don't typically find a single required distance number on an FMS page. Instead, that data is going to live on the OPT, the onboard performance tool, or the EFB, the electronic flight bag. And usually most airplanes will have these tools now to figure out your takeoff performance. And then that's going to give you your takeoff runway available, or your accelerate stop distance, give you whether you can go or not. So you can look through this. I think I got this. I forget where I got this from. Some of this I referenced, and some of this I wrote up myself. Landing data, same thing. You're going to put in the conditions, and then the OPT will figure out whether you can land or not in that available distance. And so again, we get that from the OPT or the EFB. Or your paperwork. Your paperwork could have it too, but generally most of the airplanes have the OPT calculations down in the form of an app on your iPad. And then radio communications, generally for the VHF left, and we use primary ATC, so that would include ground, tower, departure, approach, en route, center frequencies, all on the left VHF. Right VHF, we typically use that for ATIS clearance, company, air-to-air, 1, 2, 3, 4, 5, or monitoring guard frequency 121.5. And then the center VHF is dedicated to ACARS. You can see a little bit difference in this. You could see where the ATIS and the ATC clearance would be on VHF left. It's not the way we did at Boeing. And even with the airline, I don't think we did that. I think we used the right radio. They're the right VHF for the ATIS and ATC. So you're probably going to see more like this than you will the other way. But I think on the 777 it says like the ATIS and the clearance would be on the left VHF, and they put all that stuff on the left VHF. Well, in practice, I don't think it's really done that way. It could be with some airlines, but the ones I've seen, it's always been ATIS and ATC on the right VHF. ATC clearance, and then, all that company stuff and air-to-air and guard and all that. And on the 400, of course, it's specifically noted that you should not select the center VHF for voice communications. So if you use, normally that's reserved for data or ACARS if it's operational. And so each captain each pilot has a radio tuning panel, RTP. There's a left radio tuning panel, right radio tuning panel, and the center radio tuning panel. And you can get any radio on any RTP. So normally the captain will use the left VHF and the HF. The FO is going to use the right VHF or right HF on his let me see. Yeah, on the audio control panel. So again, if you go to a radio that's not normally associated with your side, you're going to get that offside tuning indicator light. So that's not to say you couldn't use the right VHF radio on the left radio tuning panel. You can, but you're going to get an offside tuning light, and then the frequency will be the same on both radios. And then I think your question was that if you have, for example, the left VHF on the audio control panel, if you had the left VHF transmit button pushed, that allows you to transmit and receive over the left VHF radio. But let's say the FO is getting the clearance on the right VHF. He's got that selected on his side, and he's calling for the clearance, and I want to listen in. Well, then I can take the little round rotary selector under right VHF and push that on. I don't have to push the transmitter selector. I just have to push the receiver portion of that, which is that little round switch. Push it down, it lights up, and then you can turn it to the right and adjust the volume. And then you could listen to the clearance with the first officer. Is picking that up. So you can listen to, if you want to listen to the PA announcement, you could turn the receiver for PA and turn it on. So the transmit selectors can only be selected one at a time. So if you select left VHF, you're selecting transmit and receive. If you select right VHF, you're selecting transmit and receive. You don't have to push the little circular selector then, because it's automatic when you push the transmitter selector. But if you want to just listen on some other radio, you can just push the little round selector, and that would allow you to listen in on whatever whatever it is. I think that was your question, I believe. And I think that's it. I hope I was clear. It seemed like I was rambling a little bit. But if you have any other questions, just shoot them my way, and I'll expand on that, or if I need to look something up better. Remember, I've been out of this for 6 years, so at least, so I have to remember things. I do miss that weather in Miami. It's getting better up here now in Minnesota, but boy, I love that weather down there on a day like that you see there. All right, Goose, well, you're in Miami, and I would say I hope you're having a good time. Well, you will have a good time because you want to be doing this. So I'd want to be outside enjoying the weather if it's nice. Hopefully you're not getting rain and thunderstorms and stuff like that. Anyhow, Goose is boots on the ground in Miami, and he's starting today, and best of luck, although you don't need it. You're very, very well prepared from anybody that you've been preparing for this for months, and you've got the flight background and stuff like that. You're going to do just fine. You're gonna have a fun time with it. Anyhow, that's it. Captain Al out. Thanks. Bye.